So it's like, because it's a 360 degree, so it looks like this in this video. So if you wear the head mount display, you can really see that you're in the seashore or no, in the sea. Okay, so the more details about this is available in vrlabs.org. You can take a look. So sound I disabled. There is another work done by students. It's also a very short clip on organic chemistry. This is a bit of a non-interactive simulation. It's a formation of different chemical compounds or explain with the proper atoms and molecules there, and so it shows how structure changes when new atoms are added. Okay, that's just short one. I think there are many chemical components you can see. I think there are about 50 or different compounds or formations are built up as of now, and we can extend this to as many as possible. And that's again, NJC students are going to work on this. The idea is further they can bring different atoms together and see where they can put them together. Just use their hand to bring all these things and just join them. And if it is a valid join, it's a valid, the property can hold, then it will say it is fine. Otherwise, the system will say it is not possible. This combination is not possible, and so on. It's all based on the chemistry. By the way, I'm not a chemistry teacher. I'm not a physics teacher. So don't ask me any questions on physics or chemistry. Okay. So why we are doing this? Okay, so we are teaching, the green energy production in one of our modules. So one of the topic is wind energy. So for many of the topics in this course, we need lab experiments to really get the student to understand the concepts clear. So what we did in the past, we used some miniature of a wind energy production system. So something like this setup. And the problems with this is, it is a very controlled environment within the lab. So what we are missing is the real-life wind profiles, real-world wind profiles. So we don't have the real-world wind profiles, so we just rotate the fan using some of our own programs. So it won't really show the real effects in the real world, and students really don't understand what is meant by making it optimal. And the second thing is, it's not flexible. We can only provide like a few different types of blades, but that's not sufficient to really produce an efficient system for a given area or given wind profile. So students should be able to flexibly build their own blades and change their size, modify their shape, and so on. And they can understand what is so-called the drag force and lift force, and how it helps to speed up how the structure, shape of the blade helps to speed up the rotation and so on. Another issue we always get from the industry, even after all this training, when people go to industry, the industry feels that your students are not ready for our day-to-day activities. Because we practice them, we give them practice with small miniature experiments. When they go to real scale, and they find it very hard to relate it to the real scale. It's so big, right? Yeah, that's, once they go to industry, they want the students to be able to build the solution for a given environment. And then the scalability is another issue. So we have like a few of these devices. So every time only a few students can go to the lab and do that, then we need to do it batch by batch. So if you want to like do online, some of these courses is really very difficult because we cannot do online lab. That's another issue. So we thought, why can't we find some solutions to make it scalable? We tried some different solutions which are already available, like you might have guessed. Lots of simulation programs are available, right? So you can try with the simulations. But the simulations, again, it provides only kind of indirect manipulation of objects. Students directly don't touch the blades directly or don't feel the size directly because it's still miniature and it's just fit into the screen. And they have, of course, specific purposes, but they are not addressing what we are actually looking for. So then we decided to go for VR, and as you know that VR, the cost of all these devices are reducing every year, and it is like nowadays it's very, very affordable. For $15 you can get a VR headset. Okay, so this provides kind of a direct interaction with the tangible objects, and you can also have real scale or real world scale visuals. Suppose a civil engineer working on a big building, he can really see the same building, he can put himself on top of the building, he can imagine he is walking on top of that building, okay, while construction is going on. That kind of possibility is, that kind of things are possible in VR today. So we see this as like a second wave of change in technology-enabled learning. Okay, so I think mobile and PCs have done a very good job, and now we are all looking for VR. Lots of devices coming in. I think you might have daily getting some news about VR and lots of new devices, lots of new startups and so on. Okay, so that's the reason we started the project. It's just very recently started. You have done something. It's a continuing project. I invite you all to join and let your students join and contribute in this project. They can build any kind of physics or engineering and science experiments in virtual environment. Okay, either they can join as a builder or they can join as a learner. Okay, so we did some preliminary studies on this. So we just want to prove that why VR is good when compared to the simulations. So one of the things we found VR is helpful is to reduce distractions because of the nature of the device. Okay, we developed a few lessons. So one of the lessons is on teaching the wind power generation, the relation between the wind speed, height of the tower and the blade size, okay, and things like that. And the second lesson is a bit advanced, it's more on the design. For example, the yaw mechanism here, which actually turns the entire system towards the direction of the wind. Okay, and there's an upwind, downwind, the advantage of like having wind from this direction, front or backward direction. So in which direction we need to like push it. There are both has their own merits and demerits. So and like understand the capacity factor. So these are like some design related things. The second lesson. The third lesson, the one you saw in the video, is actually how the organic chemistry, the reactions happen. So we got some students from our undergraduate year 1, year 2 students, and we split them into 3 groups. And for some of them, we did a normal usual study, like did a pre-test to check what their current knowledge about these technologies. And then we get the participants use different platforms. Okay, we provided lecture notes in PPT form, and then we did a normal screen-based simulation. And then the VR-based simulation of the entire thing. So we have three different versions, and we record their behavior. The entire environment was recorded, video recorded, just to see what happens when their behavior changed with different medium. At the end, Yes, we give some quiz to just make sure that they got the concepts clear. And then to also understand about the knowledge retention. 2 weeks later, after they finish all the experiments, again we send them one more quiz to take. Okay, that's to understand whether we are, because it's providing very good visuals and immersive environment, does it translate to better understanding of the concepts and better knowledge retention? That was the things studied. So there are various forms of data collected. That's one of the advantages of doing this kind of online labs. You can, of course, total time spent on the simulation, total number of interactions with each parameters. So they can change all the parameters. You can actually measure the number of interactions and time spent on individual parameters, number of interactions for individual parameters. All these things you can log. And then we have the videos and normal built-in quiz and pre-post test quizzes. Okay, so to measure the conceptual learning, we just take a simple approach. We see the difference between their score in pre-study and post-study survey. And then for attention span, we recorded number of distractions. There are two types of things we have recorded here. For non-interactive simulation, the one just they view and to understand. For that one, we just recorded the number of distractions. Okay, I'll explain that a bit later. And for interactive ones, we measure the number of interactions. The more the interaction is kind of better engaged or better attention into the project. Okay, and knowledge retention again is tested through quiz. Okay, so there was some improvement in conceptual learning, that is understanding the concepts in this case. The average difference of marks, that is the difference between their pre-study and the post-study. So at the end of all the experiments, their score has like improved from the previous score by 6 marks or about somewhere here. Okay, and of course VR slightly performs better than the normal 3D screen medium and PowerPoints. If you look into some data points, again there is one thing you can notice. There is a huge leap in those who studied VR. Okay, they have got about 8 marks more or 7 marks more than their pre-study. For attention span, we did like the simulations are like viewable in both cases, like VR and 3D. The simulation is designed to be viewed within 1 minute. So it will just, because it's non-interactive, it will auto-complete within 1 minute. If they are spending more than 1 minute without pressing replay, which means they are doing something else. Right? So that's taken as one of the parameters here. And PowerPoint slides is something to read. We have designed in such a way that with diagrams it could be easily digested in 2 minutes. If anything happens greater than 2 minutes, they are not really paying proper attention to this. Of course, there are some disadvantages in these parameters that we will see later. And then what we got is the average number of distractions in this non-interactive things. In VR, it is very, very less when compared to 3D medium and PowerPoint. So it does help to some extent to capture the attention of the students. And if you can see again the data points, VR is like the number of distractions is very, very less. Okay. But again, if anyone is paying more attention, means his scores should be higher. He should have understood the concept very well and got very good marks. So again, we taught them together the conceptual learning and attention span data. And what you are seeing here is those who are in VR, those purple lines here, they have got pink lines here, they have got higher mark, higher score, and also they have less number of distractions. This kind of tells that when they are focused, they learn better. A similar thing was done for interactive labs where they need to interact to change lots of parameters to learn. And here the measurement is more than interactions is better than engagement. So what we got here, the results are not very encouraging anyway. It's a very limited, it's almost same as the non-VR environment. The number of interactions in normal 3D and VR, it is almost same. Then we went on to analyze the video. And in the video, we observed that those in VR, they had very, very less interaction with their other participants in the study. But that again has some negative points. Those who did normal desktop-based learning or paper-based learning, read from the PowerPoint, they had lots of interactions with their participants, but those who are in VR, with the head-mounted display, they didn't have that much of interaction. For the study, it looks good, but actually, the group is missing something on collaborative learning. The people who use the normal simulation, they actually discussed, their discussion could be like positive one, they may be like understanding something about the system through discussion, but that is actually limited in the VR environment. So this gives us some ideas to build in some kind of communication and social features within the VR system itself. So for the knowledge retention, you can see that as shown here. Those in the VR platform, they had a better knowledge retention, and of course, this is a study conducted 2 weeks later after they completed the experiments. But what happened here is their score is even improved than their post-test score. The score after 2 weeks is actually, for some of the students, or all the students, improved than their post-study scores. Which means the visuals, the brain need to work on these visuals over the days, and they get better understanding about the concepts. So hence it will kind of increase in the score. And for these students, of course, there is no increase, but we are definitely improve the knowledge retention. So it's known fact that when you have stimuli from multiple sources, audio, visuals, and touch sources, you tend to remember a lot. So that's the advantage of VR, what you're seeing. So VR helps in most cases, but again, this is just a preliminary study. So this is an ongoing project. We are trying to continuously do this study for a longer period of time with more projects coming in. Yeah, the sample size is about 50, so that itself is a limitation for this, any to say anything very conclusively, but the trend looks very positive, so we are going to continue on this. And of course, one of the goals is to understand whether the students after graduating from this, are they ready for the industry requirements? Are they able to design solutions for the real life problems that haven't tested? That's again in our pipeline to test in the next round. Okay, that's what I want to discuss about the VR labs. As I said, it's just started. You can go to vrlabs.org if you would like to join us and just indicate your interest. We will follow up with you. You and your students. Okay, thank you. And I'll finish off this, then we can open up for a short Q&A. Okay, so the next one is a well-known tool. Show and Tell is basically a web whiteboard for collaborative learning. Again, the reason for this is basically explained in the slides. There are lots of Q&As, especially just before the exams, and especially modules involving lots of equations like physics and maths kind of modules. And students send lots of emails, but again, they cannot put the equations in or they cannot draw anything into the normal text messages. So we thought we should build a tool which can help to do all those things. So in this case, what happens is we want an environment something like this. Students can draw or write freely, okay, record it, or capture something from the slides or directly import the slides and then record on top of it, okay, annotate it, and then send the question to the lecturer, share with the lecturer. The lecturer should be able to open the same video file, and answer into the same video file by further annotating it or further adding images and materials into it. And then you should be able to share with the class group. The class group again should be able to open up the same video and continue asking a follow-up question or giving a better explanation and so on. And this can be continued until you feel like, okay, this is the end or something like that. At that point, you can again convert the whole thing into MPEG or normal video and share with larger group. Okay, and of course I don't know, later I'll come to the demo. But again, there are, as a matter of thought, there are many tools available to do this. Okay, but what we want is we are actually targeting simple Q&As. So we want to have a simple to use, very simple to use tool. Okay, where you can do all the whiteboard functions and as well as you can record and just share it instantly. Yeah. So, hope you are aware of many of these tools. Camtasia, Breeze, Adobe Presenter, Ink2Go, Show Me. There are many tools which can help to record the screen and do some annotations kind of thing. But all these tools are like, they are really overkill if you just want to do for a 1 minute or 2 minute short answers to the questions. Something like Quora, something like that, we are doing it over the video. Of course, you need licenses and so on for this. You need to install some program in your computer and so on. So we want a browser-based technology which does not require any installation, which does not need any plugins to be installed. Just key in the URL, you should be ready to use. And of course, the recent web technologies, they basically support this. They provide canvas and you can capture video in the web itself. There's audio features. And as well as you have a WebSocket, a browser can directly communicate with another browser in this case. So another reason for going through this is, if you want to use this, of course, you need to be connected all the time. So, but as you see, the broadband speed and penetration in Singapore is like, we are like about 90% very well connected. And most homes today have fiber network to the okay. So let's just give a quick list of features. It's platform independent, device independent, anytime, anywhere, because it's browser based. It's a whiteboard. It has normal whiteboard drawing features, and as well as you can insert animated images and documents like your slides or PDFs. Record screen and audio. Share the recording for viewing and editing. So which means you can record and share whatever you recorded instantly for viewing and editing on the same video, which is not possible in other tools which are available in the market. Okay. Once I get the link, I can open that link and I can just continue editing on the same. Export the final after the question is sufficiently answered. You can actually export it to a video format which can be played in any other device. And again, share the video for viewing. Yeah. Plugin free, installation free. That's our primary motive. No Flash plugin, no other plugins are required. Okay. Can be integrated for LMS. So whatever the learning management system like Blackboard or Canvas, whatever you use, you can integrate with that. So it will automatically pull all your class groups into it. So it will form a class groups based on whatever is available in your learning management system. Then you can do a collaborative editing, either real time or offline. Offline means I create something, I share it with my class, any member from the class can edit it further. Real time, at the same time, everyone from the class can edit the same document, just like your Google Docs, real-time editing. Okay, so supports most of the browsers on desktop and mobile. Okay, I'll just show you a quick demo. And the real-time collaborative feature, as you can imagine, two users can edit the same document concurrently. At the same time, they can chat, do a text chat. So which means students can collaboratively develop a solution. And this is very interesting. Even though it's a browser-based tool, you still have an editing feature which allows you to cut the part of video, because normally when you record video, some parts may go wrong, your pronunciation is wrong, whatever, you want to just edit it, you can just cut it and insert another clip. Okay? So very simple. You have only two buttons here. Select something and cut it, and go to any point and start record, you will record from that point. So you can insert into any part instantly. Okay. So this is a comparison of related products. I don't think I want to take time to show you this. This is a basically unique tool. Let me just go through a quick demo on this. Okay. Yeah, the entire thing is built up with the latest technologies, okay, Web 2.0, using Node.js. And the next version is very important, deep learning analytics. This again, none of the software today provide this feature. So what we are trying to do is, imagine you are teaching a maths class, and you want your students to collaboratively solve a math problem, whatever it is. So it has a number of steps. So you start the problem, any students can go in and put the next step, write the next step. Another student can go in and put in the next step if he knows. Anyone knows the next step can just go and contribute to that. At the end, as a teacher, you can see exactly which student have written which line. What is his contribution? You can exactly measure that. You will get analytics for that particular video, for that particular problem. And for the entire group, over many problems, you can get a cumulative analytics at the end. So that's what we are building today, which will be again released very soon. Okay, so that's all I have today. That's all I'm working currently. Okay, so thank you very much for listening. Just show you the tools in the web in the remaining time. In the meanwhile, if you have any questions, I'm happy to take any questions. Okay. So these are the sites. SNT board stands for Show and Tell board, and then the vrlab.org is for the virtual reality experiments. So both are very new projects, but there are for SNT board there are already like thousands of users using it. Okay. The VR Labs is just started. Thank you very much.
Do you have any questions for Dr. Anand? If not, actually I have a question to ask you. You spoke earlier part about students focusing when they are looking at it, but do you realize there was any problem with students focus in the virtual reality itself?
Okay, that's a good question. The student focus in the virtual reality itself. Okay, this is something controllable by the instructor, the designer. What the students want to view, at which point what they should get, everything, because then they cannot say anything else other than what we provide to them. Of course, there's a free movement inside the environment, but again, you can control what should be provided at what point. You can limit the distractions in that way. Yeah.
Any others?
So I opened this in one of the browsers. So what you're seeing here is a normal editor. It has all the normal Blackboard features. Even you have, if you want some grids on top of it, you can have grids. You can adjust the size. Okay, there are many features here. These are the normal things. Okay, so you can import image or you can just capture from the camera of the laptop instantly. I don't know whether the camera here works or not, but let me just try. I've tried in this. Yeah, it works. I can just take photo. Yeah, I can just resize it, place it anywhere I want. Okay, so or I can import any image. Okay, so then after completing everything, I can share a view on the link. This link I can share with anyone, but they can only view, they cannot edit. If you want your students to continue editing this, then you can go to settings, and then you can, over here you have a sharing feature. You share with group or share with individual users. Okay. Right now, for this particular test user, there is no groups created. You can create groups and share it. Okay, so I just open the document again. I'll also open the document in another browser as another user. Okay, so assuming this user is somewhere else. Okay, I open the same document. So this is the second user. I open the document again. I show which is my first user. First user is here. It's in a different browser, Chrome, and the second user is in the Internet Explorer. So here again, the user can go and do whatever you want to edit. For example, I just change the size of the brush and probably the color to some green, and just to show you how the real-time editing works. So I edit here instantly. The other user can also click and irrespective of where they are. And interesting thing is that everything works in browser. Don't need to install anything. Okay. Thank you. This one is free to use, anyone can log in and use it. Of course, you want to integrate with your LMS system, then you need to let us know. Yes. This site is just started. We are building it. In later, you can see something like YouTube. All the things will be organized over web, and all these experiments in VR environment with interaction playable over the web. You don't need to install any software again. Okay. Once developed, uploaded to our system, it will be web enabled automatically. Okay. So after that, you can just use any learner can use head-mount display and do the experiments online. Don't need to install any software. Yeah.
If there are no questions, then we'd like to thank the sponsors of this session. Okay, that brings us to the end of plenary session 2. We'll now break out into our concurrent session. However, before we break out, we'd just like to let you know that after the second part B of the session, can all our guests from the overseas countries, can you please come back to this venue, because we would like to brief you more on what the event for tomorrow.
Sorry, there have been some technical issues in TG24, so those who are assigned or going to TG24, you go to TG25 instead. It's just next to it. Okay? Yeah.
Yeah, so I will just put the venues out first for the first session. Can you please take note of the venues you're going? Basically, this is Century. The next block to us is TG block. Our teachers will lead you to the TG block. And 2.1 is next to 2.2, it's next to 2.3, it's next to 2.4, it's next to 2.5. So if you get lost along the way, it is one of the 5 classrooms. Okay, so it's just, and that block is a short block, so there's only 5 classrooms there. So yeah, you'll find the correct one sooner, hopefully. Okay, so can you take note of the ones that you need to go to first? Yeah, I will get the teacher facilitators to lead you into the different venues. For TG21, we have Mrs. Xia sitting there. For TG22, we have Mr. Alvin Beck. Those who are going to TG23, you can come and find me. And TG25, now is Miss Ning, the one with the red bag over there and checkered shirt, the lady that's very close to the door on the outside. Yes. Okay. With that, I will see you all again at the end. Thank you.